Problem 53. Determine the amplitude, period, and phase shift of trigonometric function f of x equals to 3 times sine of 2x minus pi over 2, and then graph one period. To answer this question, this is transforming a trig function, the sine function in particular. You'll need to remember the graph of the sine function. And please remember the 5-point summary for the sine function. So let me use theta for the input and sine of theta. I'll be computing for 5 numbers. And those 5 numbers are beginning of the fundamental period, 0, and end of the fundamental period, 2 pi. And then you break it into 4 equal subintervals. And that's going to give you 5 points on the graph. And then from there, you can figure out the graph itself. So the middle would be pi. Between pi and pi, 0 and pi, we have pi over 2. And between pi and 2 pi, we have 3 pi over 2. And sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is negative 1, sine of 2 pi is 0 again. And this would be the graph of sine over one period. Okay? Now, the domain for sine is all real numbers, so this graph actually continues, but the way it continues is periodic with the periodicity 2 pi, so you can copy and paste, and this gray piece is just cutting this black piece and shifting by 2 pi. Now, what I like to do, I mean, you can use formulas mentioned in the textbook to answer these questions, but I just want to prefer to use my knowledge about transformations that we learned before in this class, and I apply it to that 5-point summary. So I start with those 5 points. And those 5 points horizontally are between 0 and 2 pi. Now, what I have here inside my sine function, not x, but 2x minus pi over 2. So when 2x minus pi over 2 is 0, then sine of that will be 0. When 2x minus pi over 2, whatever is inside the sine, right? So the period, what I'm having is a period for 2x minus pi over 2. But my horizontal axis is not going to be 2x minus pi over 2. It's going to be just x. So what I need to do is to write x, get a period for my x that would be solving this inequality. And that's kind of straightforward. And that's going to tell me the horizontal transformation. So 2 pi plus pi over 2. So 2 pi, that's like scrap paper, plus pi over 2 would be 4 pi over 2 plus pi over 2, and that would be 5 pi over 2. On the right-hand side. On the left-hand side, 0 plus pi over 2 is pi over 2. Let me grade this out. And then I would divide everything by 2. And that means my period for x, if I'm thinking in terms of x, starts at pi over 4 and ends at 5 pi over 4. And from here, I can figure out the period. The difference is going to be where the period ends. This is going to be the difference of where it starts minus, or where it ends minus where it starts. That difference is the period. And that would be 4 pi over 4, which is just pi. So from here, I can figure out period is going to be pi. And that also means if I divide it into 4 equal subintervals, each of them will have, let me denote it by delta x increments. It's going to be whatever the period is. I'm just dividing into 4 equal parts. So pi over 4. So I just keep adding pi over 4s. So that would be 2 pi over 4, or just pi over 2. 3 pi over 4. 4 pi over 4. That would be just pi. And 5 pi over 4. And you can double check. We ended up at the same correct place. And nothing happens vertically. All right, so all I did was whatever is in sine, I squeezed it between 0 and 2 pi, the period where the period begins and ends for sine, and I solved it for x. And then I get a nice 5-point summary for in terms of my x. Okay. And then that's the horizontal transformation. And of course, the replace narrative still works. I mean, you can say replace x by x minus 2, shift it to the right by pi over 2, and then replace x by 2x, vertically shrink by 2, and that would move the beginning of the period from pi over 2 to pi over 4. That works too, but I mean, this is quick. Because sine is a period, I can squeeze the graph where I'm interested in. It gives me a horizontal start and end, and I can figure out the transformation, horizontal transformation that way. For the vertical transformation, I'll just do whatever. I'll do it the old-fashioned way. Replace sine of 2x minus pi over 2 by 3 times, and that would be just multiply so I just put the numbers. That I found earlier, and wherever I see y, I just multiply everything by 3. If I had, I don't know, minus 2 here, I would multiply the numbers on top by 3, and I would subtract 2 afterwards. But I don't have that in minus 2, so I stop here. And that's it. So if you have x, then the numbers on top will be values for 3 times sine 2x minus pi over 2. And so I can start drawing the graph. My period starts at pi over 4, the fundamental period. And then 1, 2, 3, 4 more marks. 5 pi over 4 is where it ends. And I mark 0, 3, 0, negative 3, and back to 5 pi over 4. And this is the graph I end up having for one period. Now, how much the graph deviates from the middle? So the y equals to x 0 axis is vertical middle for my oscillations. And the graph goes, when you're reading to the right, as you move, the outputs go up and down and up. And amplitude is how much they go up at most. That would be 3, up or down. And phase shift shift is where the period starts, and that would be pi over 4. So instead of 0, I'm starting at pi over 4 for my period. And if I draw the graph on GeoGebra, this is the graph of sine of 3x plus 3 times sine of 2x minus pi over 2, and this would be pi over 4, and that's where my period starts, fundamental period starts, and pi over 2 is the next number, right? I have my max there, local maximum, and then 3 pi over 4 is the next 0, and then I go down. At pi, I hit a local minimum, and I go up again, and this number is what, 5 pi over 4, and this is the answer. Let me check if the answer on the answer key is correct. Oh, I didn't put the graph. The question didn't ask for the graph, but if you have the graph, you have the answer to the question too, right? The amplitude is 3. How much the function deviates from its middle, these waves, like at most plus or minus 3. Period is pi, and phase shift is where the new fundamental period starts instead of 0. It's pi over 4. Alternatively, of sine, let me find those formulas. Well, I guess I can just write them here. If your graph is of the form a times sine dx minus c plus d, then vertical middle. For us, there was no d, so y equals to 0 was the vertical middle. Vertical middle is y equals to d. Amplitude would be a. Phase shift would be c, whatever follows the minus sign, divided by the absolute value of b, and period, not the absolute value of b, just b. You see, I can't remember them very well. And period would be 2 pi over absolute value of b. Well, in class, I did explain b. You can always make b positive using the symmetry of sign. But let me just quickly go to the lecture notes and put it here. I'm not a huge fan. People make mistakes here all the time, like 2 pi, or they forget the 2 pi, they forget the b, and for tangent, you have to take pi instead of 2 pi. Do you use absolute value of b or b? With this way, if you go this way, remember the 5-point summary, right where the period starts and ends, and whatever you have inside sine, just solve it for x, and that's where the period for x starts and ends, and you're done with all horizontal things. And for vertical, just take the numbers on top, the outputs, and if you have an a and minus d or plus d, just those numbers multiply by a and add that d.